a simple picture of the sheets, and it will appear in the report behind. So just look at it. And here is the video. So we can find that it is really hard to separate the two groups. And let's see why will this happen. First is the non-discrimination. We define the interleaving length is L, and the distance that have the angle is D. And then we define this. The thickness of each page is absolute. And the total traction force is T, and the individual traction force is Tn. And the number of the sheets is N. And the N sheet, the angle of the N sheet is theta N. And the sequence of the sheet is N, and this one we define it as Hn. So if D is much bigger than 2 times M times Hn, which means the total thickness, then L minus D is nearly the same for all sheets. Then we define big Hn equals to the small hn divided by D and equals to the tangent theta. So we can calculate that sin theta and cosine theta. So if we focus on one page, we can separate on 3 parts. On the first part, we have a traction force. And if we analyze log A, we can find that the traction force between A and B is Tn divided by cosine theta. And the traction force between A and B will cause a normal force to the next sheet on the book. So we can get that Tn divided by cosine theta times sin theta equal to Tn times tangent theta. So the normal force is equal to Tn times tangent, just like this. And from the picture, we can know that Tn minus Tn plus 1 equal to 4 times mu times Tn times Hn. And after some complicated mathematical condition, we can get the final formula. So let's go to the experiment. Here are our equipment: the sheets, the C10, the ruler, and the force sensor, which used to detect the force. This is our setup. So here are the parameters. We try to change M, epsilon, and L, and we want to find that the force that can separate the books, the total traction force. So the experiment 1, we want to investigate the relationship between M and T. This is the process, and I'm going to show you some pictures to know how we do this experiment. So we interleave the 2 books with 10 page, and we try to put it on the rope, and we want to separate them. The one on the top, the blue part, that is the force tensor, and we use force tensor to detect the force that find that if we have one page, the structure report should be much more bigger. And we try to investigate the relationship between epsilon and t. So I will show you the picture. We change the epsilon by interleaving two pages one time, like this. So we can got the epsilon times 2. And it is the same step in experiment 1. We pull the rope and we can detect the total traction force. And we try to interleaving 3, 4, 5 pages each time. But we haven't gotten the results, so for that. And experiment 3, we want to investigate the relationship between L and T. So, picture, and we'll have a ruler to measure the end of the overlap part. And we will investigate the force that should separate the force. But we haven't finished it. So as because of the prototype, we haven't finished the calculation. So let's finish it. You mean that one? So I think we can look at the first page. We define Z at alpha. And Tn will change to T of Z. So we can got this equation from this one. And we try to get into its answer, we got this one. And after the calculation, it will become like thanks. didn't consider the mass of the camera in your video. Yes. So why can you ignore that problem? Within the mass of the paper. Just because the mass and so it will has the weight. So because we do this experiment not in horizontal, we do it in vertical. But I think that actually when the paper file is less vertical, then maybe the shape of the pages will be like this. And then there may have some forcing which will also cause the you mean it will change the angle? No, I mean that even when the pages are hang vertical, however, there should be some forcing to stand it, to hold it pages so that because it is obvious that when the page is hanging like this, then it will start to move. It will start to extract. Here is the yes, it will move. I mean that if we don't have the force to apply to these pages, then this pages will hang. I mean, if there are no pages inside, it will move. Yes, so the book will come or it will not open much. Okay, so there should be some force we will apply to the next page, right? I think so. Okay, so why can you ignore that? So the main problem is that the page of this part has a width. Yes. Let's look at there is a width here. It is true that it will have a force to the next stitch, but okay, I think that's the theory problem, but we can't change the mass of the paper when doing experiment. If you ignore the mass of the paper itself, then what causes the initial force that will apply to the next page? I mean that, okay, so if there is no force applied to, I know what you mean. When we have a traction force on the top of it, and parameters, how the parameters should affect this phenomenon, and we will use it to support our experiment.
So, what do you think that the pages, well, if the pages without index goes linear, then what will the force become? If you interleave the pages linear, then
Here,
so
you mean the L minus D is bigger?
means that if you doubles your so I mean that if you double the pages, you interleave.
You mean you put, you mean if we do the experiment like this?
Not really. I mean that
Maybe we can draw.
here, if you interleave these pages, right, then you conduct the next experiment with 6 pages interleaved inside, then how will the force become?
You double the pages.
Yes.
Oh, okay. This is the data. The X bar is the pages and the Y bar is the numbers.
So U gas plus is the one. And how will the force grows when the pages will interleave?
If we see this from the theory, and we can guess that it should be an exponential growth.
I guess that we can find the exponential relationship between the pages and the force. And we think that there is an are placed horizontally, then the weight of the weight of the paper itself it can be ignored.
Wait, so you believe that there won't be a difference because the paper mass can be ignored?
Like I said that it can't be ignored.
It can't be ignored.
So it will influence the outcome.
So you believe that the paper is heavy enough to influence the outcome by like a lot? Or just
Yes, because
just a little or
I think it will influence the outcome a lot.
the report, do you believe that there are other causes to this phenomenon, like why the pages stick together other than parameters we have set? Like what other things can be changed? Might be changed.
You mean that have I think of any other parameters to affect this phenomenon?
Yeah.
The things we want to change is that the M and the D and the epsilon. But I think other parameters are hard to change. Maybe it could, but it is really hard. Like he said, the mass of the paper. That was really hard to change. So we won't do that this time.
Okay, thank you. So this is the prompt. So basically you interleave a couple of pages together and apparently this phenomenon happens, like you can't pull it apart. And the prompt tells us to investigate the parameters that set the limit of steaming for separate books. According to the report, and yeah, the report only did, well, one experiment, even though he did lots of theories. But in the end, he only did one experiment. Yeah, incomplete. So here's a summary of the reporter. So first time he talks about the explanation, and then he goes on to talk about the theory, how the angle may affect how hard it is to hold the books apart, and then he tells us to set up and talks about his experiment that he did or did not do, and the conclusions, yeah, so far. Like, he didn't really finish the experiment, so you can't really have any conclusions. So, some pros about the reporter. So he had a very good theory explanation. You did a very good job at explaining your tough theories. You told us the source of the normal force, even though the opponent sort of like wants to talk about that. And your experiments were very like, there were steps to your experiment. Like, you didn't just do them. You did it in an orderly fashion. And you had graphs. You have one graph to explain your experiment. So the cons, the animations were little, so you're gonna click them. There was only one parameter that was changed, and you didn't really analyze the graphs. All you did was like skip right over the page. And the opponent went back to talk about it, but you should have explained it better in your presentation. And yes, incomplete. You only did one. So the discussion. So the opponent asks the reporter, like, does the mass of the paper affect the outcome? And the reporter says it's neglected and did not really find, like, the theory does not really explain if the mass affects it or not. And yeah, the reviewer believes that the opponent was correct, and you should like consider the mass of your problems. And then the opponent goes on to talk about then what causes the actual force if you neglect the mass of the paper. And then the reporter talks about how the traction force is the main cause of the friction between the pages, and the reviewer agrees with the reporter in the fact that this is the cause of the phenomenon. And the opponent then talks about if you double the number of pages, what happens, and then the reporter pulls out his graph and shows that it's exponential. But we believe that the reporter does not do a very good, clear explanation of this theory. And the opponent then asks about the contact area and how that may affect the outcome, and then they go on and talk about that, and I couldn't really see because it's in red, and in fact that's green, I couldn't see anything. So the reviewer question, so then I asked if how you hold the pages together matters, and they both answered no in times up.
Okay, so I'm sorry that I didn't done the experiment. The opponent and reviewer gave me some great advice. For example, the opponent said that will the mass of the paper affect this phenomenon? I have never think of this, so I think that is a great suggestion, but it could not be experiment. So I think it is the real hard thing to do. And then the reviewer talked about that I have no theory for the experiment one, but I can calculate it for you now. From this formula, we can see that T equals to, oh wait, you can see red, so T equals to like this, and so when we change F, the other is constant. So it will truly be an exponential growth function. Yes. So thank you everybody.
Question for the report: did you measure the coefficient of friction?
What?
Coefficient of friction.
Oh,
friction will remain constant. Start from the
摩擦系数会在时间中维持一个定值。
Yeah, it's
why is it?
because the cause of the friction is that because the little bumps on the surface that will influence the coefficients of the friction. So then when we pull the hammers to another case, then the coefficient of the friction may cause that little bumps has been yes, or maybe if we do this experiment for many times, then the paper, the surface of paper will become so flat that the coefficient of friction will become lower.
And he done the experiment like that. In our experiment, we do one paper for some period, 5 times, but it didn't decrease. Sometimes it increased. So I think that if we do it in 10 times, maybe the number will be constant.
That's the reviewers opinion.
The reviewer believes that it would have been better if the reporter had done like one paper for one experiment, but due to the fact that we have monetary fund issues, we believe that the coefficient is constant enough for the equipment of our school.
One more question for the reviewer. And you asked the reporter, are there any other parameters that you consider in this experiment? So do you have any suggestion for that? What's more parameters that you can do?
The reviewer believes that the reporter has done a very good job in explaining many parameters, but all his experiments all lead up to one problem, like the change of the angle. So we believe that maybe gravity could have an effect. The thickness. The paper thickness, the paper weight may have other effects on this phenomenon.
那因为摩擦系数其实会跟它的肉，就是它怎么报？就是我压一张纸的压几张纸，最好会变，肉越大的话，它的会越小。所以这看，我就只是问这类的问题可能是评审
对，评审每一个评审不同答案。那他其实那个中间有那个总结，就是说，像这个问题，其实我之前刚好那个大陆的那个，上次跟大陆交流说，他们那个上次我是教那个电子排异，然后大陆他们是要教那个摩擦力，然后就今天呢，其实问了几个老师哦，那其实大部分老师哦对这个问题自己都不了解。那可是我刚问到几个，其实大部分没有几个老师是蛮厉害的。那他们有几个不同见解，就是说这个刚刚中间讲的那摩擦系数其实是一个麻烦地方，就是说一般来讲在讲我们定义摩擦力跟摩擦系数是一个接触面，这样可以吗？一个接触面的话，就是一般来讲就是摩擦系数是定值，然后跟正向成正，这样可以吗？可是今天很多接触面的时候，就我的感觉就是那时候大家讨论的时候就对会诊前大概两种看法，就是说你如果很多接触的话，就当然就是等于你要把这些东西的线叠加起来，所以摩擦力是变成你合理的，就是如果在一起这些这样，那另外一种说法就是刚刚中医讲，就是说那你如果刚 谁讲到说要改角度？不是我刚中间我对对，你刚说改角度是不是？你知道改角度怎么样？你说改变角度是不是？
他是说叠的页数变大，
它叠的越厚，
他应该是说那个吧，
哦，对。
report 的东西。
对，没有啊，我想起来，他刚讲那我会说那一可我觉得刚我误解，但是我觉得就是我误解的意思还蛮有趣的，
不解的话也
所以你看我一样的条件哦，你要去比这是我一模一样的条件哦，水平拉，跟我以前都想水平拉跟尖子拉就是看，可是你今天可以就改变角度，你就放个斜面嘛。 那拉的都可以。那你先只要一模一样的条件，只要水平拉，然后比如说改个10度或30到90度，那你看一下这个差别。以前我最早用这个点我那时候想说就是立起来拉了，就水平对。
装置很假，
不然这样你就用个桌子，甚至就桌子就垫个课本，没有，我知道大约啦，就说你知道一个桌子嘛，就那个书桌也好，我就垫个几本书就会有斜面，然后就是只大约就好了，我就其实有没有很明显？但是我们如果确定有明显的差别的话，就做更精准。但是你只要做起来角度，比方说30、60、90，你告诉我它的差0度30、60、90这样就好，看有差别。因为这个很麻烦，就是你今天这样拉起都，我这样讲好，上次对我记得通常好像是凤青那时候我跟你讲过，其实还有一种做法就是说。 到底，因为你这样拉，其实我很好奇，就是你张数越多，然后拉力会变大。因为你那个张数，你是用1张A4纸，你说的是哪一本书？
加 S， 然后把那个定数机上去。
那然后你接触的面积，你有加到很深吗？还是说直接加？
第一个是我做的那个实验还没有改到深。
那你多深？
我第一个实验是15，
就一半。快一半，对，那一半就你可不可以再做，就是说？ 至少你做个比如1/4、半，甚至3。
你说差不多的时候，它会散开。
对，因为我在想说，因为这样讲嘛，因为之前我提到有，忘记还是帮我讲是谁，就还有一个做法，就是说你可以怎么样来平衡。然后正向的眼睛，你就是这样，正向的怎么改变？就是因为你一样越多改变，一样越多。今天有个简单的做法，就是说你可以用那个电法之类的，电法之类啊，我刚才讲，我想就用那种比较硬的电板，然后比较硬的电板，你把它，中间你可能就是用个那个简单，就用个那种厚纸板，然后把它隔开，就你电板就一层一层一层一层，做个5层10层然后那个不然呢，就是电板有一种，然后你中间都留了差不多1公里、1、2公里的空隙，每一层。那今天怎么做呢？今天就那个放那个纸进去。 你没有说，你放纸进去，然后而且你1张纸不够，你可以放2张纸3张，然后去看，就说我今天如果是，因为我们今天压越多层，你下面那一层跟上面那一层的正向会不一样。但是我今天如果因为你电板是够硬的话，它每一层接触面的正向都一样，明白？这样会把问题就解开。因为我今天，比方说你今天如果叠100张跟叠200张，除了接触面积。 好，然后什么可能之外，它因为越下面那层它的正向可能越大，这样可以吗？那还有一个关键是你起力的话，你会有大家会考虑，就是说它会有一个你如果它有个 bending 的效应，那像 bending 就是你有扭曲的话，就有正向力会改变，知道？所以那就是做成在类似的风琴叶，就风琴让你一层一层做。我忘记看到谁有这样的，还是我忘记了。那你就一层一层做，然后上去拉，而且它的面积你可以做，你就全部放进去拉。 那跟你放1半或身体拉看看，我不知道，我很好奇，这个做出来就可以把问题再更理清一点。说到底，那说明就类似像比如风景讲的制作，如果在当时就
说像洗地嘛，
我也是就是什么问题？
就是有洞的怎么做？
然后呢？
它够宽了，所以它边中间不会挤在一起。
对，可是这样子你还是不，因为它是重量，你没听懂是？因为如果是那种硬的那种亚克力板之类的，或是塑胶板，你每一层你这一层的重量，你这个接触你重要指那一张纸的重量，这一层就要指那一张纸的重量，这时候就完全就我们把正向应该是那个又简化掉了。你如果是像你用那种活页纸也是这样，活页纸我下面那层就受到上面。 对，是正向力还是重力嘛？当然这几个都要理清的，就是你那个角度的也会但角度的可能还是会，就其他的角度的也马上没到理清了，就这里都如果要多看，这样会把问题在，因为我们现在还是一团乱，就是因为像你看那个什么秘发他们在做实验，就是他是用了他压了你注意看他两本书是几乎叠到完全密合，然后他又很用力的那个夹子去夹住，所以他那个正向力是超强的。他最后分开始都没关系，都是发就行。好，那我们就是再把那个泥巴，当然还有几个了，关键就是面积，关键你再考虑说这奇怪，这题不会，你们要再会诊一下，因为对今天早上还有谁问我一个很蠢的问题，就是说你们可不可以一起做实验？而且你们当然一起做实验了，最后你们赶快会诊，然后要把3组的东西你们不是各自做3个，是大家去会诊，也不是说你最重要，你也不是说你做3题，我做5题，就是不是这样，是大家都要做，因为我跟你讲，之前我们最早我讲过，我们最早那期怎么做，3对嘛，做很轻松啊，3对分一分，1人分4题，那就 OK。就问题是，你到时候你别人做事，你根本没办法报告啊，那你讲的时候根本破绽百出啊，对吧？所以你每个实验你都完全了解，这样才有意义，好不好？好，然后还有这个还是像你刚刚我觉得有点可能说，现在说你时间不够长，所以没有写。很危险，你要很快就大概几句话，先把他的那个概念就先写出来，这样别人就当然，像我一开始是还当然 OK， 但是我希望你尽量可以把它就是呈现的，因为至少你要把你做那么多事情，大概有简单的写，这些能够会讲。这个是很重要的能力很多人这不是你们，就很多学生搞了半天，最后写都讲不清楚，他自己不知道他怎么写。好，那当然你现在看起来当然没有清楚 ，OK， 好，那还有你的那个影片的效果申报。完全，你在我一般的影片大概干嘛？你知道证明说他很用力，然后跑不起来这样子，对吧？我感觉这个是，可你，很强我一直笑，我觉得效果还不错啊。对，可是，不要给啊，好不好？但是这里他申报你要说的，对，没有，这不是，但是你呈现出来，大家就这样过去，然后你没有，你这个是报告技巧，你要让人家知道你要干嘛。你说这个，不是，我觉得事情有时候会当下。你现在看，你觉得好笑，可当下每个人都知道你在干嘛。没有，那问题就在这边，你的报告技巧，所以就说你先这个断掉之后，你就说这一个我都考了，然后就是这样，这里有至少你要说这句话再稍微这个效果，我觉得这个理论上是有效果。我有点猜到，我那时候有影片给到你们要做一些，但是因为当下这听说完全没有人有反应，这样就有。这你们自己说。为什么你报告的时候就你们自己的是不是笑要死，然后什么都没笑？这样子不包括之前有对，最常见就是说他们有些人他们自己觉得很好笑，然后大家都知道，这个不是这个比没有人笑还要重，因为这个太辣了，有没有？你的影片要拍的够齐，你们的影片都不够清楚，拜托你们可不可以赶快去想办法做？你们需要他们都会做，中军你帮他们，你们就是他们学校都用布啊，用什么那个。用到厚纸板，甚至他们好像有，甚至你去用那个什么科展的作品的看法，只要你是去做嘛，不是？这个小型你们我们就找几个类似那种看板，然后把我围起来，是我这样找的早期没有，早期他们有一个那种很小的，然后这也是那种国际科展有同学带回来，是那种厚纸板，不画好画一个是吧？那个就9分的对啊，对，那种纸板那一种啊，之前有人拿回过，后来。我有看，因为我们学校是在硬的，很超大、超重的画，不过看看你们自己赶快弄一组，然后实验装的尽量都在里面，或者你各组做一个类似摄影棚，好吧？那个效果会比较好。还有，对，你刚才在讲什么 big H、small H， 一般人不是这样讲。你刚才念那个说，难道我听错吗？那都是，那个说 big 啊，那个就那公式，big H。上面。对，你这种对啊，这当然是应该是会，这个是 KPH 跟 H 就好了，对你。你不要生气了，没有？你讲 A 型讲 那种 difference 嘛，这你感觉是不是更相异的？
对啊，对啊。
对呀，这样嘛，就是说the difference between two pages 或怎么样，我不知道，因为我这样大概我都不知道你在讲什么，但是我大概可以知道，但是你要再把这个比讲，现在看就知道在干嘛。那你刚才要训练，现在你看你跟大家讲，大家比赛在学，这样要不然你念到符号其实大家是都在干嘛，这个会，或者而且你们符号慢慢去改成大家比较一看就知道的话，尤其是像这个，你干嘛去换成 Z？我也不知道为什么，它有时候变成 A， 这种还是 A。
这是做笔写的。
那更重要，你这边要瞎别人
没有，它上面别人写说为了让人放大。
不是啊，我就是来，全部注意听，拜托，全部注意听，那是谁？后面那是谁？他这边是谁？你发的好。那等一下上课好来，你就要，我跟你讲，注意听哦，你用到的公式只要不知道会用那种，好像是怎么在干嘛的，注意听，你这边一定要，好，那个你们不要怀疑，你们先。你黄牌2.9张了哦，满3张都没有来哦，每天都在闹，真是，你到底有什么贡献你说？你真的，你们先注意听，我也在听，你们一定要这边就加一个 reference， 就什么，比方说这一个 review later， 然后第几页哪一年的，他们有一定 reference。
那我在第2个很多都要写。
都要啊，没有，你要搞清楚，你只要那个东西出来哈，
写不会被打。
就会啊。那教授那边就，但是没有下去的对手程度太差，他说这是什么？他可以他论文吗？那论文你怎么看？你为什么要相信论文？这个就不用讲，他这样讲，他只会一直被扣分，那代表他程度太差，因为教授他
会有分数，他会有分数。
那也无所谓啊，不会影响你。你看他刚才你说也是的哈，但是这个通常论文会经过严谨的。你不要露出不屑的眼神哦，不要像那个，不要像徐伟成这样。
不像啊，他考的是条例制度漂亮。
哎，你越来越像少科员了。对不起了。
多少分少的呀？
那还是读你有那个实验室就可以了，那个点要再大一点的，那个有一个你那个点要再大一点哦。对，那个你就不要去里面看，但是那个点要大一点。这你要再你用颜色，它再大一点，
可是之后就会发现没有理论值。
好啊，但是有理论值，你的实验值点要大一点，这样看得很不清楚啊。就是在这样，因为评审通常都坐在最后面，教室的最后面，好，然后那个，好，那这你们好像直接再补一下，至少有教过出来，好 ，OK 吧？好，然后右选，哦对，右选你刚刚又在把题目在那边玩，你还是不知道，你还是你们要赶快改，你们讲的都还是字还是太小，好，然后再是那个你题目再讲一遍，
太小，因为不太小。
不管，因为它就算不大题目，它因为它的，我讲你那个框框它一定是很小，就你至少比例上再把它拉大一点，就你大题目也会好看，好，所以你字真的很多了，要不然一般就字要大一点，好，尽量大都没关系，只要你能够看。好，那第二个就是你题目在重念一遍的时候，我强调过，你要知道你要有什么目的，好，比方说我要在。
他说他要找那个限制，所以
对，所以你要把那个限制的好，
所以
我把它框起来，就是没有。然后对，还有那个，对没有，你要把你那个红字或反白或把它弄清楚，就是说这个东西他没有做到之类的，这个很正常。以后再打每一组的 opponent review 都要做这些事情的，好，就是你再讲 OK，但你就说他刚刚整份报告里面，他这几件事情没有做到，让他明确好。那包括 report 也要去，如果你每份报告你到最后结论的时候，你再把甚至你把我会要求同学再把题目再放一次。题目要做这些，那我都做了，这样可以吗？那有的时候是怎么样？真的比较不好是题目要做这些，那我做了这些，那这个是有什么问题做不出来，或是没办法做，再讲清楚，这样可以吗？不可能全部都没做，但是你得是自己在那个怎么样，在打预防针，就说我们大概好，这样人家大概就要挑好一点，你不要说我真没做，然后是人家提出来，然后说啊对，这个我没做，这样对方就这样，就等于是有点类似好像盖我的缺点。那我就明白来讲说，我不是不做，是真的做不到或怎么样，或做了之后效果不好或怎么样，要就可以把report就可以自己先把那个讲出来，好，这个要注意一下。所以你最后 conclusion 的时候，最后再呼一下题目，好，这个要注意到。好，然后最后就是我刚刚讲的那个什么 我觉得每一个图都还蛮清楚。因为你刚刚就是我看到一些框，但是字就感觉就小了一点，可以吗？因为说真的，有些教授眼睛真的很不好。有几个教授，尤其教师那种高中技术，真的，因为每天在那写论文在那边看，你知道我们很多教授他眼睛真的是不好，所以你可能怎么大都 OK， 再尽量在哪里？好，好，那今天就先这样讲，那明天继续啊。对，还有那个科展的部分，你们都要讨论一下啦，就是那个你们，因为我要跟那个主管汇报，你们现在就把每一道题，你们自己在题目，我会想每次说，我这个这样在讲，我还有没有同学可以出来，你们不赶快去，你们就每一道题目，连各种的名称点一点，那你们就可以去讨论哪几道题目你们想要报的科展，然后就可以去凑对，差原上3个你对，好不好？所以最少一个我建做可以做，除非你最近哦，除非有了这你讲，除非比如你今天要报数学科展，或是要报生物课，你已经做了差不多了，那我就不要求你要再报物理。但是如果没有的话，你每一个人都一定要认两件，哦，还有那个玉伟的玉洁，好，你要加进去，好吧 ？OK， 好，那先这样 ，OK， 好，明天中午再怎么，明天报告是谁？明天谁？明天谁报告？
明天是报
罗顺，对，他明天就要跟他讲12点10分，拜托你们12点就要过来了，罗顺听到没有？12点就过来了，你12点过出来接啊，我来的时候我看到不好，然后12点秒针一跳到12点10分就马上开始，听到没有？
从现体地要报告，
随便拿下不要再吵，
今天12点10分也只有我一个人，
不管。
在那个讨论那个阶段，但之前你想说是反应好。